Hello, welcome back. There's some gap in my videos. I'm going to now give continuously the lectures to you. Let me dive straight away get into the Dynamics 20. This is a continuation of what I started last time. The frictional cases when you have two bodies. You see, that's what I'm going to give you now. In fact, this is probably what I try to give you, that there is a force applied here. There is friction there, there is friction there. This is one case which we saw. The other case we're going to see, if I apply force on the upper body, what are all the scenarios? That is what another thing that I'm going to see. Then I'm going to see both are pushed, all are rough surfaces, the same scenarios, and here I'm applying force on the lower body, here I'm applying force on the upper body, here I'm not applying any force, I'm only pushing it once, and here also at different velocities, same velocities. In the entire friction chapter, I think this is one of the most crucial aspects. If you get this concept clearly, I think things are going to be much easier. Then I think this case is already did before. I would like to give you the essence of it. I took that all bodies were slipping first, that's how I started up, so that F minus F2k minus F1k is M1 on the lower body, and M2 is the pseudo force minus F2k, that is equal to M2 AR. AR is like this, F2k. Then the 2 AR is relative acceleration. That's how I started off. Then I went on to discuss. I first found out what is the AR, then if this length is L, what time it takes for it to follow, all those cases are given. In fact, I took initial relative velocity 0, SR is L, time is T, so SR is URT plus R ART square. But this is 0, therefore we got T as, that's how I did it, and then went on to look at what is how does the frictional force vary. I remember those cases. If I take the lower body frictional force, if F is equal to KD, then I took, that's how it varies. This is F1K or F1L. So from then onwards, it remains constant, 1, 1, 1, 1. It's only to tell you that it pertains to body number 1. Then what about the F2K? F2K till this body moves is 0. And then we found out its slope was not like this, and it will go. So this is how your frictional force varies between the two bodies with the time. This is what I try to explain. Now I hope things are clear. You need to work on them twice or thrice in order to get a feel of it. Now let us get into the next scenario. This is F is applied on the upper body. Now I am presuming all are sleeping. How do I write lower body? Why should lower body move at all? Because of the frictional force by 2 on 1. So that will try to take it forward. Since you said the upper body is also sleeping, I am putting F to K. Now how this moves, I will show you here. After some time, this is the scenario. This moves, both will move. Okay? F to K, obviously, if you try to move this will tend to oppose. And as before, this is M2, this is M1, this is M1G. Let us say its acceleration is A1. Is this clear? Now how do you write that? F2k minus F1k is equal to M1A1. Okay? What about the upper body? Now I told you every time we do friction, better to go with relative acceleration wherever feasible. And here F2k would be opposing, since A1 is like this is, but AR is forward because you are pulling the body. How do you write that? F minus F2k minus F minus F2k minus M2A1 is equal to M2AR. First establish these relations. Now, let us solve for AR first. So, how do I do that? A1, I will replace here F minus F2k minus M2 F2k by M1 minus plus M2 by M1 F1k. This by M1 is substituted, so M2 by M1, M2 by M1 minus, and if you take it minus M2 F2k plus F1k, right? This is equal to M2AR. Alright? Now, well, F2k, a common, this plus M2 by M1. What is F1k? mu1 into okay. What is F2k? mu2 M2g. This is M1 plus M2 by M1. This, if I am writing it as like this, that's how you get it. Okay? Alright. Now, what is AR? AR is equal to, I think in this something is common, you can see. m2 by m1 into m1 plus m2. This is mu1. So I write f minus m1 plus m2 by m1 into m2 into g minus this is mu2 minus mu1. I've combined these two terms. This, the whole thing is common, right? So I can do that, and the whole thing is divided by m2 because m2 AR. So this is the answer. And once you get AR, what time the body falls off the lower body? As before, I told you SR is equal to L, UR is equal to U2 minus U1 initially 0, time is T, therefore T is equal to under root 2L by all this minus sigma m by m1 g mu2 minus mu. You can rewrite that also if you wish by taking m1 and m2 here. Anything is possible. So you can do that. This is the first thing, very simple thing. When I apply force on the upper body, what time the body takes to fall off? Now let us go to the special cases. These are important. These are very, very important. In fact, I will write the equations here. F2k minus F1k is M1A1. F minus F2k minus M2A1 is M2AR. They are the two equations that I wrote in the beginning. Now special cases. How do you go about the special cases? First of all, what is the condition for the lower body never to move? Condition for lower body never to move, no matter what F is. You may give any value of F, lower one should not move. What do you mean by that? First of all, you should understand lower body I am putting it. I said this is F1, this is F2. Now the maximum that you can have here is F2L. Maximum from the upper body. But you don't want this body to move. Therefore, F1 must be static. What do you mean by static? That means it is F1s. So, no, I can't apply any force. Therefore, lower body cannot move, but the upper body moves because you are applying the force. So, here it remains static. What do you mean by that? So, suppose the limiting frictional force here is 20 newtons. Here the limiting frictional force must be say 30, 40, 25 likewise. Then this cannot be more than this. So that means If it is to be F1 as F1L must be greater than F2L. This is the condition for lower body never to go. Okay? Now, what do you mean by this? Mu1 M1 plus M2 G must be greater than mu2 M2 G. Or I reverse it. mu2 must be less than mu1 and M2 also you bring it onto this side. mu2 must be less than this. This is a very important case. Now, suppose I am taking M1 is equal to M2. Suppose. Then what is this condition? mu2 must be less than 2 mu1. So, what is very important here is mu2 is less than mu1 is necessary condition but not sufficient. mu2 must be less than mu1 is necessary but not sufficient. Bold letters I am writing. This is where your advanced cases come into picture. You never say mu2 must be less than mu1. That is not enough. Suppose mu1 lies in between these two. This is not possible. So, condition is number one, mu2 must be not only less than mu1 but much less than that because 2 mu1. I will give you an example. Suppose mu1 is equal to 1. mu2 suppose is mu2 must be less than 2 mu1. Suppose. No, mu2 is, sorry, 1 second. Okay, mu1. If I take mu1 to be 1, mu2 must be less than 2. That is the condition. This is crucial, I'm telling you. Now, this statement is slightly problematic. I will correct it. mu2 must be less than 2. That is the meaning of it. Okay? Now, suppose mu2 is equal to 0.5. Suppose. Then also that is valid because that is still less than 2. So here, please correct that statement. That previous statement I made is not correct. I am making another statement that mu2 need not be less than mu1. Please correct the statement. Previous statement was not correct. It was wrong. mu2 need not be less than mu1. It is, suppose if it is less than mu1, definitely that is possible. But even if mu2 is greater than mu1, if it is less than this, so I hope this point is clear. Suppose mu1 is equal to 1, mu2 is equal to 1.5, m1 is equal to m2. Is the condition satisfied? Let us see. mu2 must be less than 2 into 1. So what is mu2? So 1.5 is less than 2, therefore valid. So mu2 is greater than mu1. You get the point. If it is less, it's definite. But mu2 can be greater than mu1 also. For the lower condition for lower body never to move. Okay? I hope this is clear. Don't get confused. The previous point I think you have to ignore. Now, first case we saw. What did we say? Case 1. Mu2 must be less than this one. What is case 2? Condition for this to move, lower body to move, then obviously this is important. Now I think I got a little confused what I was talking about right now. Let us take, because this is just reversed. So what if I take mu1 is equal to 1? What about mu2? Mu2 should be greater than, if I take m1 equal to m2. So mu2 must be greater than 2. Now here that condition is applicable. mu2 if I say greater than mu1, that is not enough. mu2 must be much more than mu1. So, for lower body to move, mu2 being greater than mu1 is necessary, but not sufficient. It is necessary but not sufficient. I hope you are able to follow this. Okay? So, this is the condition for lower body to go. Okay? Fine. Now, yes, that's fine. Now look at this. I want to take the frictional forces. Same concept as before. Same concept as before. First of all, the moment I start applying, what will no body is moving, all are standing. How do I write this? This is F. F2, yes. And F1S. M2, M2G, M1, M1G, that's all there. This is M2, M1, M1G, M2G. These are all well-known things. I'm avoiding it. Now the acceleration is 0, therefore F2s is equal to F1s. Here F is equal to F2s. So that is equal to KT. What do you mean by this? Both bodies will have same frictional force. You get the point? So I will try to draw the frictional force. Now, F is equal to, so the both 1, 2, 1, 2, 1, 2, there. Let us presume that you want the lower body to move. upper body should not start slipping. So, next case, what do I do? This is the first case. Enter. T is equal to T1. System starts moving. No slipping. So both will move as a single entity. So how do you write the? He says F2S, N2, N2G. Okay? But lower body, F2S, F1L, N2, N1, M1G. This becomes F1L. And T is equal to T1. You get the point? Now it starts moving. You get it? So, what is the equation that you write? It's a scenario. At this instant it happens. At T1, this is the scenario. Suppose more than T1. T greater than T1, system moves. The whole system moves. Upper body doesn't slip. Upper body doesn't slip. So lower body, how do you? That is still F2S, but this is F1K, N2, N1, N1G. How do you write? F2S minus F1K. Okay? Right. Now, upper body. F. This is F2S, M2A1. AR is 0. No slipping is taking place between the bodies. They are still moving together. So, how do you write here? F is equal to F2S plus M2A1. What is our interest here? We will find out what is F1K basically mu1 into M1 plus M2 into G. Isn't it? F1K, you will have a constant value. Fine, we will see. What is F2S? We will find out from here. I'll write it here. F is equal to F2S plus M2. What is A1? Whole divided by M1, so I have written it. Okay, so what is F2S? 1 plus M2 by M1 minus M2 by M1 F1K mu1 into M1 plus M2 into G. Okay. Now you bring everything onto this side. What do you get? F, which is KT plus M2 by M1. If I take it M1 plus M2 into G into mu1 M1 is equal to F2s into M1 plus M2, M1 plus M2. Got it. Now M1, I get. So what is it I am getting here? I write that value here. F2 is equal to M1 by M1 plus M2 into K into D plus mu1 M2. This is a very, very important result. What is the slope of this? I think I will draw this diagram little below. Likewise, okay? Now, system starts moving, therefore, this is 1, 1. Mu1 into M1 plus M2 into G, that is 1, 1, 1. But F2, what is the slope? Y is equal to mx plus c. If t is 0, this is a positive intercept. And the slope of F2, the slope here is k. Right? Here slope is 0. No longer it varies with time. But this one, F2, slope is less than, so it can't go like this. Likewise, it will go. And like that, this initial time with t, this is t2, and here, this is how the frictional force varies. If you extend this, what is this intercept? Try to understand this problem vis-a-vis the previous problem. Totally different aspects. When I apply force on the upper body, this is the situation. And when I apply the force on the lower body, the situation is different. Now I am going to give you here, this is the case, this is F equal to 30, 1, 2, and here the first case, 1, 2, lower body applied, and then this. You can very clearly see this is T1, this is T2. Both the cases that you have here also, that is mu2, M1G, you will get. At a glance, if you see, you will get some idea of how things move. Try to have practice on this. In fact, if such problem is given in the exam, you will get only in advance. In which case you have to work out then and then itself. And if you do that practice, you will get it better. Is that clear to you? Right. Now, I go to one, two, U. And as usual, I am taking this over here. This body falls off the lower body. That's how the bodies move. what time it takes for the body to move off. So, what you have to see is, first look at the lower body. Lower body, FVD, how do you draw? Why should it? Of course, you are pushing this and this, therefore both are valid, but this is slipping more. Once it starts moving, of course, you have F1K, and since this is dragging on this, so F2K will be forward on the lower body, M1. So this is N2, M1G, N1, same as before. Let me presume that this is A1. How do you write the equation? F2K minus F1K is M1J1. Okay? Now what about the upper body? This is going with you. Therefore, pseudo force is M2A1. Okay? When you are applying force, the first body, you saw that if you force this, what will happen? This will also push it forward. This will also push it forward. So that is pushing forward. Now, one important thing here is, be careful. You are saying it is accelerating at A1. The fact is, it is retarding. It will stop eventually. So, your A1 is right. I'll try to explain it to you here itself. This is F1K. This is F2K. But it is retarding. Therefore, minus A1 in that direction. Or A1 in this direction, because you pushed it. So how do you write this instead of minus A1 here? In which case, because A1 is like this, pseudo force will be M2A1. And what is the relative acceleration direction? Because you said this is falling off. You may say, what if it doesn't go, this goes forward? It will fall there itself. So there is no problem for you to work on. So how do you work out this? I hope you have understood my concept. I'm saying, this is F2K, F1K. But this body will eventually stop. Means this must be more than this. So, there is a retardation in this direction or acceleration in this direction. So, pseudo force. Therefore, so what do you write? M2A1 minus F2K is M2AR. Now, A1 you eliminate as before. So, how do you write A1? I am writing A1 here, F1K. So substitute M2 by M1, F1K minus F2K minus F2K is M2. Therefore, M2 by M1, F1K. What is F1K? Minus F2K means mu2 M2G into 1 plus this is M2 by M1. All this is AR. Okay? So, what is still common in this? I think M2 by M1, M1 plus M2 into G. This. G. That will leave you with mu1 minus mu2. K, of course, that is. So, how do you write that equation? U are 0, AR is known. So, T is equal to, what do you write? 2L by AR, M1 into sigma M G. This is very simple once you get it. In case upper body, lower body have different velocities, then what do you do? The same thing, only thing is, look. And U2 is greater than U1. UR is equal to U2 minus U1. And this is L. SR is equal to L. Right? This will follow. So everything is same. AR is also same. Only difference is AR you take from there. Now S star, or rather, L is equal to U2 minus U1T. Yes. Yeah. Plus T square. So, this is nothing but UR. So, how do you write your time under root of UR by AR plus 2L by AR minus plus both are in the same direction. This is the same equation as I have developed before. So substitute AR and get this. Now, this is, what is UR in this case? U2 minus U1. Now, possible 1, 2. See, this is This is U2, this is U1. Then UR is equal to U2 plus U1. No other changes. So you have to simply work on this. Okay? Is this clear to you? Fine. Work on these cases on your own, and then I will come with another topic next time. Thank you.